Hello, good morning, good evening, good afternoon, depending on where or when it is that you're watching this webinar. I'm going to take the first few minutes just to give everyone an opportunity to join before we get started. But really excited to have my good friend now, Jay, here for a wonderful conversation. How are you doing today, my friend?
Really, really good. How are you?
Fantastic, actually. The Atlanta weather is good. It's getting nice and warm. I'm starting to wash away a lot of the pollen so I can actually breathe on a regular basis now. So
Yep. Yep.
Oh, things are off to a good start. So we'll just give it about 1 minute here, and then we will go ahead and get started.
Great.
Alrighty. Well, I'm now showing 2 minutes past the top of the hour, so I'm going to go ahead and kick us off. Hello everyone. I'm honestly really excited for everyone that's chosen to join the webinar on EPSS, the Exploit Prediction Scoring System, featuring Jay Jacobs, the co-creator and co-chair of EPSS. So my name is Cortez Frazier Jr. I'm a principal product manager here at FOSSA. I help lead our vulnerability management product as well as our software bill of materials lifecycle management solutions. I'll be your host for today's discussion. Before I go over our agenda and introduce Jay, I'd like to cover just a few housekeeping points. First, we're going to try to answer as many audience questions as they are submitted. But if we can't get to them throughout the webinar, then at the end, we'll make sure to have some time for Q&A. So please post any questions as you have them in the question section throughout the webinar, and we will address those from a contextual basis. Next, this webinar is also being recorded. We will send that out to you after the event. And then finally, we at FOSSA will be following up with you after the webinar with a few additional resources to see if there's anything that we can do to help your organization with vulnerability prioritization and management. Um, Now, let's take a look at today's agenda. As you see, there are about five main sections in our webinar. We'll start by explaining what EPSS is, giving a high-level 101 there, what the different scores mean, and why EPSS is an important part of the vulnerability prioritization conversation, and a fantastic input for that workflow. We'll then transition to a discussion of the EPSS data model, its many inputs, and then before closing out with a bit of bigger picture look at how both EPSS compares to other vulnerability prioritization models, but also how to use EPSS alongside these other prioritization inputs, and show at least a real world example of how to do that in practice. Um, After that, of course, we'll have a little bit of time for Q&A, which would be awesome. And, so we'll be able to get to continue to pick Jay's brain there. Now, before I hand things off to Jay, just a quick word for those of you who are not familiar with FOSSA. There are kind of two main parts of our platform. One includes solutions for managing risk in open source software that they use. You can think of these like the open source licenses that are being used. This also includes prioritizing and remediating vulnerabilities, which is obviously the focus of today's presentation, in addition to license compliance being a supplementary workflow that we support. The kind of second part of our product is then on the software bill of materials lifecycle management offering. This is going to enable organizations to automate everything from generating SBOMs to ingesting third-party SBOMs from their user to then analyzing any SBOMs that you ingested to then have insights on securing your software supply chain for both your customers and then any software suppliers or vendors that you're using as well. Um, Without further ado, I'm really excited to introduce our speaker for today's webinar, Jay Jacobs. Like I mentioned, Jay is the co-creator and co-chair of EPSS. So there's absolutely no better person to speak to of the nuances of the EPS model and how to best use it in practice. So with that, Jay, I'll hand things over to you to share a little bit more about your background.
Sure. Yeah. Thank you. My background largely in data. I actually started out my career in IT and security over 20 years ago. And around 2010, I was studying a lot of risk analysis and risk management and found that a lot of that actually tied back to statistics. How do you measure the things that we're observing? And that led me to go back to school for statistics, got a master's certificate in applied statistics, and been working with data ever since. I got a job at Verizon shortly thereafter, working on the DBIR, the Data Breach Investigations Report, and haven't really looked back. Wrote a book, 2014, Data-Driven Security. Probably wouldn't recommend it. There's a lot of good material, but it's probably dated at this point. Also started a group mid-2000s, 2008, I don't know. CIRA, the Society of Information Risk Analysts, and lately I started Scientia in 2017, co-founded and the chief data scientist there. So we could probably jump into it, Cortez. We can jump into EPSS 101.
Absolutely. So I'll kind of kick off with my, high level understanding. I'm sure that you'll have a, much more deeper representation throughout the rest of the webinar. The way that I like to present EPSS for those who are unfamiliar is CVSS, in my mind, attempts to quantify the possibility of a particular CVE being exploited, where EPSS, tends to give more context on the probability of, that particular CVE being exploited, giving all of this additional data that they're now able to obtain. And so taking, real world threat information, real world threat attempts, likelihoods, various data sources, combining that together, and then coming up with a probability to help you from a prioritization input. How would you say that I did on that one, Jay?
Perfect. Absolutely perfect. Yeah, just to add to that a little bit, one of the things that EPSS started from was research about exploitation activity. We had one great data source around exploitation activity, and we started saying what could be used to predict this? What can we use to model that data? And so that's how it was born, and it just evolved from there into the scoring system.
No, and I'm very, very thankful. When I think back to my shoes, being back in a security professional's seat, just drowning in a sea of CVEs and having no really high quality ways to kind of go about prioritizing them, right, and kind of cutting down on that list. And so I'm curious, kind of from your perspective, why EPSS? I think I'm planting the seed a little bit there, but I definitely have something.
Yeah, you really hit the nail on the head. I mean, I think any organization that has done any sort of vulnerability discovery or scanning knows what the environment looks like. It's pretty overwhelming, I think, would be the understatement. And this picture here where we've got this Venn diagram, every possible vulnerability that there could be is in the gray. And then that little red circle is what we're actually seeing exploited in the wild. And depending on when you look at it, between 4 to 6, maybe 7%, depending on the slice, perhaps lower depending on data sources and all that sort of thing. But very few are actually being exploited in the wild. And so when you get a list, you get the old style phone book where it's like this thud of like a vulnerability report, and you have to go through them and say, all right, what do we prioritize? And unfortunately, like CVSS, I think over half of those with CVSS scores right now are high or critical. And so it's really hard to prioritize when 58% of everything is high and critical. So if you have regulation that says do 7 and above, you're doing nearly all of them. And it's crazy. But anyway, you want to go after this little red circle. And so this is why EPSS, when you look at the scores that EPSS produces, I would say probably 80 to 85% are extremely low. And it sort of helps bubble up things that we expect to be exploited. And we can definitely dive deeper into that. But this is an example too. In this particular Venn diagram, we put in CVSS 9 and above. This blue circle represents everything that is CVSS 9 and above. You can see the overlap. And I think anybody who's worked in the space knows that there's no perfect scoring system. There's nobody that's going to say, you only have to patch these and you can totally skip these. Skip any patch is not something in any vulnerability manager's vocabulary.
No, absolutely. Right. And I think that when I think about both my customers' experience and then my experience as a practitioner, one of the things that we consistently run into is it's almost a math problem to a certain extent. If I am a developer and my security team has mandated that I must say solve all direct, critical, or high CVEs. To your point, I that may cut my list down to the single hundreds. But if it takes me 30 minutes optimistically to investigate each individual CVE, the reality is I probably only have about 2 hours per day. So 4 CVEs per day throughout these hundreds that I can truly investigate and before even having the ability
Yeah.
to take action on, right? And so I think you've actually introduced some really interesting concepts to me as well on how to think about that prioritization problem, and specifically how to get the best either coverage, effort, or efficiency out of that. You want to chat more about that one, Jay?
Yeah, absolutely. We have three metrics, I guess you could call them, and they're pretty simple. I mean, when you break it down into how we're doing it here, where you've got like the true positive, which are things that you want to prioritize that are actually being exploited, and then the false positive, things that you are trying to prioritize but are not being exploited. That's a false positive. False negative is when you say I'm not going to prioritize it, but it is being exploited, and obviously we want to avoid those. And then the true negative are those that you're not going to prioritize and are not being exploited. That's the larger bucket typically. And so, like in this case, we want to start out with effort. And we want to, with these metrics, there's going to be trade-offs. You can either make one better or you can make another one better. You can't make both better at the same time. And so like effort is like a base level, like how big is that blue circle basically? We talk about it relative. So how big is that blue circle relative to the gray circle? And in this case, it's the false positive and the true positive, which is the blue circle, over the everything, the sum of all four of those categories. In other words, the gray circle. And so this talks about effort. So typically we'll see, like when we looked at this in practice, and we were partnered with Kenna Security, we looked at companies, about 350 to 400 companies that had vulnerabilities. And when we looked on a month-to-month basis, they were able to remediate on average 10 to 15% of their open vulnerabilities in a given month. And so that effort, we could say roughly 10 to 15% is a pretty good target effort. And what we found is that when people would remediate smarter, they would have a lot bigger benefit than if they just did a brute force, let's just increase that effort. And of course, effort has real translation into money, into how much staffing, how much time are my current employees spending on this particular effort. And so knowing that effort is going to be a really good indicator of that cost, staffing, time, all of that. And so that's what effort is meant to represent.
Yeah, and I can tell you, effort as a product manager is one that's always at the top of my mind as we are constantly walking this balance between, how much tech debt, for example, can we invest in while ensuring we get the biggest return on the value from a security perspective.
Yep. And related to that is efficiency. So like if you say you're doing, 15% effort, you want to know what out of that 15% effort, how much of that is actually going towards the most critical ones, the things actually being exploited. And so if you look at this Venn diagram, you've got that blue circle. How much of that blue circle is overlapping with the red? And so that blue circle becomes the denominator, and then the overlap is the numerator. And so you've got the true positive, how much that you got correct in your remediation efforts and your prioritization out of everything in that blue circle. So in an ideal world, if the red and the blue were perfectly overlapped, you'd have 100% efficiency. Everything you're prioritizing was what you're meant to prioritize. And if the blue circle was smaller than the red and totally inside of that red, you'd have 100% efficiency because everything you said you're going to prioritize is going to be exploited. And typically what we see is more like this, where there's just a little bit of overlap. And so efficiency can range, like typically when we measure CVSS and this stuff, we're seeing between 5 to 12% efficiency. And so that's basically when we started out, that was our target to beat. How do we make our efficiency? And the next metric we'll talk about coverage. How do we make those better than CVSS?
No, I absolutely love it. The efficiency one, I think, is the one that paints to me the clearest picture of impact, I would say. And so being able to understand how I am translating my efforts, to your point, to real world exploitable vulnerabilities is, I think, honestly, the answer that everyone in this webinar is looking for, right? So,
Yep. Yeah, definitely. And we don't have one for coverage, apparently.
Yeah,
Do we have, if we go forward, is it out of order?
maybe right after this one. Let's see.
No, we can go back to the efficiency and I'll talk about what coverage is, because coverage is basically how much of that red circle was prioritized. And this is really, I think when companies go to prioritize, this is what they want to maximize. They want to maximize the coverage, right? They want to prioritize and remediate everything that they think is a critical, or in this case, is going to be exploited over the next 30 days. Now, the way we did these charts, by the way, is that we looked at the scores, like say on the first of the month, and then we waited a month and looked at how that score performed. So we're able to look back and say this was exploited over that next month. And that's how that red circle is generated. And that's how we're looking at these metrics. But coverage, again, is that red circle. How much of that is covered by the blue? So like if the blue were inside the red, the blue is smaller, and inside you would have 100% efficiency, but the coverage would be less than 100%, right? Because you're not fixing everything being remediated.
Right.
And these are the two metrics, coverage and efficiency. You can get more coverage, but typically you're going to be less efficient. Or you can improve your efficiency, but you're going to reduce your coverage. So there's always a trade-off between these two. And this is a business decision, right? This is a risk tolerance compared to the effort. Like I want to put in so much effort, and that's going to get me this efficiency and this coverage. I can increase that effort, maybe get more coverage, but it's going to reduce my efficiency, that sort of thing. So it's always that trade-off, always trying to get after it.
Absolutely. Go ahead. Sorry, Jay.
On the next slide, I was just going to go into some real world examples of this. Yep. So these are very, very simple variables, if you will. And I don't think anyone would actually say this is my only prioritization strategy, So like 7 and above, no one actually just does that in practice. And it's very hard because you get clustered patches and things like that. But if you look at this, like the second one from the top left, you see that CVSS 7+. What happens is, like, here's the case, 7 and above, it's 57.4% of the CVEs in this data. You get 81% coverage. So 81% of that red circle is covered by the blue, but the blue is enormous. There's a whole bunch of blue outside of that red. And so it's not very efficient. There's a lot of effort to prioritize that 57% of CVEs. You get about 4% efficiency. About 4% of that 57% was actually exploited. And there's other examples here, like exploitDB in the upper right. If there's an exploit published in exploitDB, you're going to get about 35% coverage, but it's more efficient than CVSS 7. So like if you're really concerned about every dollar spend, maybe that's a better strategy because you're going to be more efficient. You get less coverage again, but it might be, more efficient.
No, that's honestly extremely helpful. I mean, and I think honestly, Jay, where this kind of raises a question in my mind is then what scoring breakdown do I look at from EPSS to try to get the best coverage over some of these metrics? Like I know, so for example, something my customers ask me constantly is, hey, Cortez, can you quantify, a EPSS probability above 80% as some form of critical or high grouping that I can, really kind of go after? Can you give some insight for those who are thinking about EPSS in that frame?
Yeah, and we've got several charts, and I think they're coming up. And that's really what we're going to get to, I think, is the thresholds.
Yeah.
And so, but like, this is just an example. Like if that red circle, in this case, I was looking at December 1st, 2022. And on that day, for the next 30 days, about 4% were actually exploited in the wild. And so you would expect any sort of prioritization thing to target those 4%, right? And like I talked about, CVSS 7 and above in this case was like 50-some%. Really, really low efficiency in that one.
Yeah, no, completely. And so I know, honestly, sorry, I got a little excited and got ahead on the thresholds part. Maybe you can help us better understand the EPSS data model as a whole, and what particular inputs I'm kind of going to describing that.
Yeah, definitely. So this is, I think, what most people care about, and it can get really confusing. So basically the variables here, there's over 1,000 variables. I think it was like 1,400 variables or something. And a lot of those are vendors. So like one vendor becomes a variable. Either this vulnerability is affecting that vendor's product or not. And that's taken directly from the CPE data that was being enriched by NVD, and we're trying to figure out how to shore that data up, which is a
Absolutely.
whole different discussion. But looking at this chart, the other challenge is that this is not a simple model. So like people are like, hey, can I have the model so I can tweak, the value of Microsoft, for example? We think it's going to be higher. And the challenge is the way this is a machine learning model, and essentially it's a black box. And this chart is trying to estimate the contribution of variables across everything. And you can see at the top, I think this is super interesting. The top one is count of references. So if you look at the CVE record at cve.org and you look at the number of references, this is the number one indicator of future exploitation activity, which is insane to me, something that simple, right? And you can just do it. And so like the average, it's actually been dropping over the last few years, but like if you look at all CVEs, it's about 4 references. And the last couple of years, it's between 2 and 3 references. But if you see something with like, I think Log4Shell is up over 120 references at this point, And so like if there's a lot of activity and a lot of references, like that's a really good indication that this is an important thing. You can see other things here like the tags of remote and code execution. So remote code execution, pretty good indicator. ExploitDB having exploit code out there. And you'll see that also like GitHub is on there, Metasploit for exploit code. These are pretty good indicators, and so on and so forth. And so you get all these variables. The trick with this is that this is a average. And so like the number of references is not a static weight. And so this is a hard thing to describe. And I'm get a little bit in the weeds here, but like if you have a Microsoft vulnerability, it's going to have some value. But if you have a Microsoft vulnerability and it's an RCE, remote code execution, then Microsoft and the RCE flags are going to have different weights when they're together. It's called an interaction effect. So when these two variables appear together, there's like a third weight that appears in the model. And so like what happens is that these individual variables then have different weights depending on the context and other things being set in the model. So it gets really confusing, but this is sort of an average looking at these types of things in the model. And this is just like the top, 25 or something, and there's 1,400 in there.
No, honestly, I've had to kind of go back and restudy some of my statistics courses over the past this weekend, so I could kind of brush up on the modeling perspective. I think that interaction effect is so unique. I think if I were just to drill down on this slide one more time, I'm curious on what is your hypothesis? I think it's actually a really interesting insight that the count of references has such a large impact to predict exploitability. I have my own hypothesis. I'm curious on yours.
I would like to hear yours, but mine is just like the social chatter.
Yeah.
When there's more chatter and more people talk about it, there's more material produced. And the CVEs has a semi-automated process. The CVE Secretariat, I believe, has some process that goes out and looks for these references in a very defined set of sources. And so like there's a automated component to discovering these. And so when a bunch of sites start talking about, for instance, Log4Shell or whatever the latest, hot vulnerability is, there's going to be a lot of things written. So more blogs, more advisories, especially if it's a multi-vendor, like a shared library across multiple vendors, you're going to get a lot of advisories, a lot of references show up in here. And so, and it's a long tail, like it's not the normal bell curve. This is like, everything's at 2 or 3, and then you get a few that are, several dozen, over 100, and I think it's just a reflection of social chatter.
Yeah, I would say my hypothesis here is this is actually very similar to kind of going viral on YouTube or going viral on Twitter from this lens of it creates this echo chamber effect that, very similar to, when my aunt starts to give me, cryptocurrency advice, it's probably the right sign that I should go ahead and cash out my chips. I think CVE count reference has a similar problem there.
Yeah, definitely. And then, but the interesting thing is like, what if there's 7? What if there's 7 references? Like if there's 100, that's fairly obvious. And actually, like one of the things I talk about with Log4Shell is if you were working in the space, it was like December 11th, 2021, I think, or to 22, I don't know, whenever it was, if you're working in the space and you wanted to check the EPSS score for Log4Shell, you were doing something wrong. Like that was so obvious when it hit, like everyone everywhere was talking about it. There were literally dozens and dozens of blog posts within 3 days, so like if you were saying, no, wait, I'm not sure if I need to remediate this. I want to go check EPSS. Like, you're doing it wrong. Like EPSS is a backup.
Yep. Yep.
Um,
Yep.
like if you don't know, then go check EPSS. But if you know something, like, and we always talk about this as sort of post-threat intel. So like if you know something is being exploited, you don't need to know the probability of exploitation because you know it's being exploited, So like, why would you go look at EPSS if you already know the answer,
No, absolutely. And I think well, I'm going to switch to the next slide. I think you continue to hit on a theme, which is always EPSS is purely one input to prioritization, is not the end all be all as pertains to prioritization. I think as much as we would all like, the magical silver bullet in the vulnerability industry in particular, the reality is the only true solution is maintaining accurate and up-to-date inventory and upgrading on a regular basis to ensure that your components are properly being maintained, right? So that's my early preview into the coming up. But no, Jay, honestly, on this slide, I'm really curious if you can help some of our viewers understand some of the differences between the score and the percentile, how that plays out for an impact, and then interesting as well, maybe how some of those things may change over time.
Yeah, definitely. And so, like, one of the reasons I like this slide is that this is the entirety of what EPSS produces. Basically, for every CVE that's published, you get 2 columns of data. You get an EPSS score and a percentile. Like, it is not complicated. The output is that simple. So you can just look up a CVE, look at the EPSS score, and the percentile is just another representation of that EPSS score. And so the percentile is basically saying what proportion of everything in this list is at or below the same score. So like that first one, 2019 6438, when I pulled this data, the EPSS score was 0.3%, right? 0.003 something. But the percentile was 68%. So 68% of the CVEs were actually lower than that, at or lower 0.003%. If you look at like the fourth one, 3577, that's at the 99.7th percentile. So like there's 0.3% of the data that was actually scored higher than this. 99.7% of the CVEs were lower. And you can see the probability on there was 97.3%. Really high chance that was going to be exploited. And so on and so forth. And so that percentile is basically a ranking, between 0 and 100%, what proportion are lower than this? And the EPSS score is a probability. Now, there's a challenge with probability. Probabilities seem simple between 0 and 1, very, very simple from a scoring perspective, but people get upset because, one, it's skewed. So like at the bottom here, you get like 1.9% second from the bottom, and 86% of things are lower than that, right? It's kind of crazy, but that's the way reality is. Like most of these are not going to be, not going to be exploited. And there's a great quote, like probability gets super weird under the covers. When you start working with probabilities, it gets super weird. And there's a great quote from a statistician out of England. I wish I could remember his name, but he studied and taught at Cambridge, still teaches at Cambridge, I think. And he said, I spent years trying to figure out why people found probability so unintuitive and difficult. And he said, after all of these years of studying, I figured out it's because probability is unintuitive and difficult. Like when you get into it, it's a really weird thing. And so one of the things that we do with this probability is that we calibrate it. So like when we say something has a 1% chance of exploitation, people are like, well, tell me, we talked about that. We alluded to the threshold, which we'll get to. Tell me where I should fix above and where I should fix below. But the truth is, like, if something is rated a 1% chance, about 1% of those rated at 1% are going to be exploited. Like you can't say, oh, it's 1%, it won't be exploited. There's still a 1% chance that we will see that exploited. And for that reason, and just naturally from the modeling, the scores never hit 0, never hit 100%. Like it's always somewhere between 0 and 1. And so that's a hard thing to try and get people to understand, though. Like 1% still could be exploited. And so you get people saying like, hey, you rated this at like 2% and it did get exploited. You were so wrong. But not really. I mean, like if you look at everything rated at 2%, we would expect about 2% of those to be exploited. So we would be wrong if like 8% of those were exploited. Then yes, our model would be overconfident or underconfident in that, So, yeah.
Yeah, no, honestly, the probability conversation and continuing with my completely off-topic themes reminds me so much of playing any loot-related game, and it'd be like, oh, there's a 90% chance that this extremely awesome rare loot is going to drop for me, but really that means there's a 10% chance that it will never drop on a continuous basis. And
Yeah.
often I find myself in that 10%. So no, I
Yeah.
think the
Yeah.
more that we think about vulnerability remediation from that same mindset, the better off we'll be as an industry. So.
Yeah, there's a really great there's several great probability things to talk about. Like one of them is actually called the coupon collector problem. And it's also like baseball cards. So like in order to get a card that like you're trying to collect a baseball team, and like when you go buy a pack of baseball cards, there's a really good chance that you don't have any of them, right? But as you get to like the last card that you don't have, you have to buy, like 300 packs to get that last one. And this is something a lot of games fail at, like the chance that that last one won't show up for a really long time is really high.
Oh yeah.
That's why I say like probability is so unintuitive when you really get down into the weeds.
Just my last kind of follow-up question for you on the percentile versus EPSS score. Something that similarly customers are asking a lot is, if I have to compare these two scores, I think the first org very clearly promotes vendors to display both. And so the question then is, how do I look at that from a prioritization standpoint? In my mind, the percentile feels like the more relative score as pertains to assessing
Yes.
risk within your organization. Is that true from your perspective as well?
Absolutely. Yeah. So you can think of the EPSS as like the score is the probability, which is a true probability, but the percentile is basically the ranking. So like if you go back to the bottom here, like that 2006 vulnerability, I don't know what it is, but it's rated in the 86th percentile. So like if you have a 15% capacity, like you can fix 15% of your vulnerabilities, and this is one of those, and you can do the top 15%, you may want to do that. Even though it's rated below 2% chance of exploitation, it's still in the top 14% out of everything that's rated. So that you can think of the percentiles like a linear scale. Like if you were to plot the percentile and we didn't have any duplicate scores, it would be a flat distribution, a uniform distribution across between 0 and 1.
Absolutely.
And so you could start at the top and just go down.
No, that makes a ton of sense to me, and I think honestly, this slide is actually one of the most exciting ones to me personally because
Yeah.
it really starts to attest to the impact of EPSS and how that can then affect some of those earlier concepts that we talked about earlier. I would love to get your insights on this one.
Yeah, this was something we created to talk about the evolution of EPSS. And right now we're doing version 3, the bottom right Venn diagram. But we progressed through version 1, version 2, and version 3, and we made a huge benefit in version 3. We made a huge progress. But like if you just compare like the left set where the blue circles are all the same, we wanted to maintain that level of effort, about 15% level of effort. And you can see in the upper left, when you're doing CVSS, that says 9.1. So CVSS base score 9.1 and above. By the way, no one does this. Like that is not a prioritization method for anybody. But if you just followed CVSS hardcore and only the base score and you didn't have temporal or anything like that, and even the CVSS group says don't do that, by the way. But so we're picking on CVSS very unfairly. But in here, like we're doing 15% of those CVEs, we're getting 33% coverage. So about 33% of that red circle and about 6% efficiency. When you look at that EPSS v3 on the bottom right of that the left 4, you see the threshold is 0.02%, basically 2.2%, or 0.022. Anyway, you get about same 15% level of effort, but you get 90% coverage and a 24% efficiency. So we're improving here coverage and efficiency at the same time. So working smarter, you can change coverage and efficiency at the same time, but within a single model, you always have that trade-off. And if you look at the right side, this is basically trying to hold that coverage the same. So if you say, hey, I've got a risk tolerance that says do CVSS 7 and above, you've got that upper left circle, and you got a whole lot of things you're doing. You're doing 58% of the CVEs in this particular data pool. V3 for EPSS in the bottom right, that effort goes from 58% to 7%. And you're getting the same 82% coverage. You're getting that same risk tolerance from the coverage perspective, but your efficiency now went from 4% to 45%. So you're doing a lot less effort, you're a lot more efficient, and you're getting the same amount of coverage. And that's really the benefit. It could be like a cost savings. You're able to really prioritize and pinpoint in. like this strategy still misses some. So like the threshold here is 8.8%. You're still missing some. There's still red here that is below that threshold of 8.8%, right? So.
No, 100%, right. And I think honestly, this is the perfect segue. We've kind of talked about this, or we've alluded to this threshold concept a few times here. We'll love for you to kind of dig into that, because to your point, I think all of us on this call are like, okay, how do we get our efficiency to 45% with 82% coverage, right? With only 7.3% effort. That sounds like music to my ears. So help me and the audience understand this threshold concept a little bit more.
Yeah, this is my favorite plot, and it's super confusing, which is why there's all these words across it, trying to help people track what this is. So vertically, up and down, you've got the value of the metric, and there's 3 metrics on here that we've been talking about. Effort is that dark blue line, and then efficiency is the green line, and coverage is the red line. They're all on a 0 to 1 scale, so they're all on the same scale, but they're very different metrics. So, and then left to right, you've got the EPSS probability, and this is on a log scale. So if you say, for example, that 10%, that far right arrow going up and down, if you say, my strategy is going to set my threshold at 10%, and I want to do 10% and above for EPSS. What that means, you can look at where the 3 lines intersect vertically. So like at the bottom there, you have effort, which is about, what, 8%? 6%, I guess, 6% effort. And the green line intersects for efficiency about 53%, and coverage is about 80%. So if you move that threshold left or right, you're going to shift. You're going to, like, if you raise your threshold, you're going to be reducing your coverage and increasing your efficiency and reducing your effort. If you go left, if you reduce your threshold, you're increasing your effort, increasing your coverage, but reducing your efficiency. And so this is a chart to say, like, one of the things that we often get in the EPSS SIG is, tell me what to fix. Like, you guys probably get this all the time. I see the score. What's critical? What's high? What do I fix? Where's the threshold? Right? It depends. Like, if you are very risk averse, if your organization is in the financial sector, which has a lot of people targeting financial sector for money, you may have a very, very different risk threshold than someone, say, in construction. It could be very, very different set of risk thresholds. So for us as a central organization to say 10% and above is high, like, that is very selfish of us to say, like, everybody has that same risk tolerance. It's not true. So like for a financial organization, maybe they want 2% and above, or 1%, or something like that. And so you want to be able to set that threshold wherever you want. And hopefully this chart can help you understand it. So this chart was aggregated across real data from, March 7th to November 1st of last year. So I looked at all of the predictions that EPSS made on a daily basis. And then I looked forward 30 days and I said, was that, what is the efficiency and the coverage and the effort? And then I averaged it and I created these lines. So this is real world data about this, the performance of this model.
Yeah, this is without a doubt one of my favorite slides in the entire webinar, for sure. One I'll continue to already have my product brain tinkering on how we can actually better represent some of these thresholds natively within the application itself, right? And specifically, I think the thing that's interesting to me is something we get a lot from our customers is, how do we translate our business context into inputs for prioritization? And I think oftentimes that's not even at an organization level. Frequently that is at either a P&L level or even a team level. And so giving enough, granular controls to be able to say, hey, for this, subset of externally facing crown jewel applications, my threshold, my risk tolerance here is going to be very, very low. And thus I need to lower my threshold maybe accordingly versus something where, it's internally developed application, has no internet exposure, has no access to any critical data, and then be able to operate that a little bit differently. So, Well, Jay, we've had a couple. One question come in for you that I wanted to ask you real quickly, which is, how frequently is the EPSS model being retained? And then a part 2 of that, is it stateless or active learning?
So retrained, it is. We've been doing it about annually. The last one was last March, actually a year ago last March, so March of 2023. And we actually been monitoring the performance. Like this chart, like I said, we have the scores, and then we look at the exploit data that we've been collecting and see how it's performing. And so we do see some degradation over time, and we're due to retrain. And we need to retrain anyway to help shore up the NVD problem. So we're in the process right now of retraining, but the scores are produced daily. And so, with that performance, if we saw it dip way down over 3 months, we'd be retraining every month or something. But the fact that it's almost exactly where it was a year and a half ago, we don't have an urgency to retrain. But on a daily basis, we will. So like every day we go out and grab data from all these different sources. So like if exploit code was pushed into Metasploit, which is a pretty strong indicator, that score is going to shift, right? And we haven't really talked about the score shifting on a daily basis, but over time, this will shift. And this is another way it's not like the base score for CVSS. This is sort of specifically more the temporal stuff for CVSS, where based on real world events, it's going to change the probability. So if all of a sudden it's super easy to run Metasploit and hit the enter key and you're exploiting systems, now we're going to see there's more likely that we're going to see exploitation activity in the wild. And so we need to adjust that priority. And the model does that for us. It looks at all that. And then the stateless versus active, I think that's what I was just talking about, is sort of that, I don't know which is which, but it's sort of an active thing because it's actively collecting data on a daily basis and producing new scores. But we don't retrain daily. It's the same model that we run day over day, but with different data and updated data every day.
No, absolutely. And thank you for that. I don't have my contacts in today. That R really makes a difference, honestly.
Yeah.
Yeah. Oh, through the words. Awesome. And then we got another question around, will the session be available on demand? It's absolutely being recorded. And so anyone who's attended or registered for the webinar will be able to go back, revisit that. I know it's a ton of, useful information jam-packed in such a small amount of time. And, per usual, very, very great to have you here, Jay. I think, before we kind of go into our next session, just wanted to kind of call out a few of these other prioritization inputs that are adjacent and oftentimes used in tandem with EPSS. I think most of us are familiar with CVSS, the Common Vulnerability Scoring System, that being, to your point, in a interesting space at the moment, but we'll continue to, have hope that MITRE and the MVD will figure out a strategy moving forward, but that is still a scoring system that is very valuable and one that we'll all continue to rely on a regular basis. I think we have VEX, the Vulnerability Exploitability Exchange. This one is near and dear to my heart personally, as kind of owning a lot of our software build materials roadmap, being able to, in my opinion, unlock a lot of the real world usability of SBOMs beyond just having an accurate inventory, but then having a more dynamic, consistent updates on being able to explain, are these particular vulnerabilities in the way that you're using them, in the context that you're using them, actually exploitable, and then be able to communicate that to any downstream consumers of your particular software. I know SSVC is also another one that a lot of our customers use very commonly. At a high level, you're going to take different data decision trees, such as, data exposure, internet facing, what kind of access, privileged access, things of that nature, to then put together a framework for how you should be prioritizing vulnerabilities. There's also the CISA KEVs, the known exploitability the known exploited vulnerabilities, which is a public database of that information, but there's also, you kind of called out Metasploit and ExploitDB as well, which I would consider to be adjacent sources to the CISA KEV. And then, more organizations continue to launch some of these other vulnerability scoring systems, such as the vulnerability impact scoring system from Zoom. So that was, my high level overview for anyone who's not familiar. Anything else you wanted to add on those, Jay?
No, there's always, up and coming and some outdated ones, but yeah, I think it's a good list.
Awesome. And so then there's that big final question, which is, not only we understand the data model, we understand the impact, we see the value, how do we go about implementing EPSS in practice?
So this is where my risk management training kicks in, because this is taken from the NIST SP 800-30 guide for conducting risk assessments. But every risk framework that exists, even outside of cybersecurity, has basically some type of external force, a threat, and then some type of ability to resist or evade or not feel that threat, and then some sort of outcome or consequence or impact, whatever it is. So these three things, right? And that's sort of here. So these two boxes on the left are threat events. EPSS is just that side. And this is a really critical part, because a lot of people, like you mentioned, external facing versus internal facing, that's going to affect how successful that attempted exploitation is going to be. If you have compensating controls, are you even running the service? Is that vulnerability even present? So like if it's not present, obviously the probability of it being exploited is 0. Like you do not have any risk, but the EPSS score may still be 5%. So like the EPSS score is just the threat side. It cannot tell you anything about the context. It can't tell you anything about your compensating controls, your assets, and it can't tell you anything about the impact, whether it's on your crown jewels and you've got every bit of intellectual property in the system. No idea, right? And so as you try to implement EPSS in practice, you want to understand like this is one part of the equation. Like we talked about the threshold. If you want to do some triage, if any of these 3 are 0, the whole thing is 0. So like triage, I could see triaging with something like EPSS to just get the 100% down to 20, 30%, and then focus the context around those or something. But still, like if you have a really, really important system, you might have a totally different EPSS threshold than something that is not important and buried behind a whole set of compensating controls. Like you may have a totally different threshold for remediation on there.
No, absolutely. And one of the interesting things I think when you were kind of explaining how the model is both retrained and then rescored on a daily basis, there's also then that fact that the EPSS score and percentile are going to change over time. How do you have that kind of continuous risk assessment based off of those initial thresholds that you've established, which allows for you to go back and reevaluate and reiterate over the course of those triaging and continuous vulnerability management activities?
Yeah, like I also equate that like that changing over time. Like I think of like a story of like you see someone in the distance and they're so far away you don't really consider them a threat, but they get closer and you realize that their hand is in the air and you're like, wait, is there something in there? Your threat level goes up a little bit, and then they get closer and you realize that they're actually waving, and your threat level goes way down. So like as things change, your threat level does shift around. As we see it published in Metasploit or whatever it is, these things are going to affect the overall probability that we expect to see in the future. And then on the next slide, I think it's just the same point on the next slide. Yeah, this is the fair taxonomy, which again, like EPSS is one part of this whole taxonomy. And it's just reiterating that point here.
No, 100%. And I consider the changing a feature, not a bug, right? I know like when I speak to some of my customers, they're looking for these very kind of static point in time decisions. And I think the more that we all are migrating, in particular in this open source space where things are changing so quickly, I think that's where, in my opinion, some of the more traditional security approaches begin to fall down. Even just concept of, hey, I want to pre-approve a package for usage before you bring it in. Okay, great. But that is the approval status of potential EPSS scoring on this component or on TVs associated with that component at that point in time, and that gives you no context as to what that will look like 6 months from now, a year from now, 2 years from now, right? And so, how do you kind of make a permanent upfront decision like that without having some form of continued review process? Or at least I know that's something that we run into constantly.
Definitely.
With that said, I am going to jump into a really quick demo before we hop into our Q&A. And this is, me then wanting to show how we think about using all of these prioritization inputs that we just discussed, in particular leveraging EPSS to then operate within the FOSSA application itself. So let me go ahead and share my screen here. Alrighty, perfect. So everyone should be able to see that. What you're looking at here is the FOSSA application itself. I am in my global issues view, and so imagine a scenario where I am a security professional, and I have to figure out how do I start to wade through the sea of 805 issues. Some of the things that I immediately want to start thinking about is what is my scope, right? Going to your initial point, Jay, of, hey, this is one input to prioritization and this is on the left side, but without understanding the business context and the actual impact of these things, then it doesn't do me too much good. And so thinking about, say, my Monstars, because this is where most of my critical applications are, and then I'm worried about my third-party risks as well, so I'm going to take a look at some of my software build materials, starting to get that list of vulnerabilities down just a little bit, but let's take it a few steps further, right? I may need to focus on my crown jewel applications that are externally facing, and maybe I'm only worried about the ones that are in production development as well. And then taking a look at, say, direct dependencies, just to kind of give us something a little bit more actionable to start. And this is, great, right? Like, we really start to trim this list down to about 56 or so. But I think that's still, frankly, an overwhelming amount. Going back to that, 4 to I think 15%, or no, I'm sorry, 10 to 15% that users are able to do on a regular basis. And so what our customers are constantly asking for is, where do I start? Where do I begin? And then being able to sort by EPSS and doing that highest, I think immediately starts to expose things to my mind, which is like, wow, look at these CVSS score 7.5 vulnerabilities that are actually more likely to be exploited than the critical vulnerabilities that I was showing before, and the ones that had a higher CVSS score. And so I could have actually spent a lot of effort, as we were talking about earlier, on vulnerabilities that actually were not going to give me the coverage that I was looking for, thus dramatically reducing my efficiency. And so this is how we start to then apply some of these concepts in practice. And immediately I'm like, okay, great. I have 4 that I probably want to go after. I can see which version to fix to for the CV itself. And then if I would like to go to a safe version that has no known CVs associated with it, I can go ahead and get that remediation advice, dig deeper into these vulnerability details just to make sure I'm truly impacted, and then be off to the races. And so I did only want to do a super, super quick demo, but wanted to take some of these theoretical concepts that we talked about, apply them to a real world situation, and help you understand how that can dramatically cut down on that sea of 805 that had no idea what to do about. And now I have 4 very actionable vulnerabilities for me to now go after.
Yeah, that's awesome. I love seeing stuff like that in practice. It's so cool.
Yeah. Oh my goodness. No, trust me, I'm very, very thankful of all the hard work that you and your team have done. With that, let me get my slides back up here. There we go. Okay, perfect. And then the last piece with the last few minutes here, I wanted to open it up for Q&A. Let's see, we'll give just a minute or two to see if anybody else has any other questions that they would like to populate. And so far though, like, you've honestly taught me a whole bunch, which very selfishly I'm very, very thankful for. And you have my brain churning in so many ways. I really think that threshold concept is one that is not spoken about enough. And one that I think that there's probably some novel ways that we could better surface that. Even if I could ramble for a second, I imagine a world where I, as a user, can actually then start to generate my own interpretations of the score based off of now including that business context and saying things like, yes, here's the threshold that I've established, here's the EPSS percentiles or CVEs that need to go after based off of that threshold. But how do I then start to fine tune it for my crown jewel and externally facing applications as compared to my internally developed ones, and then actually publish that back to whatever SCA tooling is being used. That way I can kind of do that on a continuous basis. So anyway, super excited, planting that seed for things for people to look forward to.
Yep. Yeah, and it's a little bit of a disadvantage because I've been studying and working on vulnerabilities for literally years. And so like when I get in a talk like this, I tend to like go fast and dump a lot of stuff. So hopefully I didn't overwhelm folks, but yeah, it's a lot of great material to talk about. And I really love the subject. So
no, absolutely. I think it's a lot of information that is coming out. It looks like we have one question that came in, Jay, that I do want to make sure I have an opportunity to ask you. It says, is there EPSS for AI ML models and LLMs?
Nope. I will say not yet. To extend that, so basically, like we could talk about vulnerabilities that don't have a CVE. If there is a vulnerability in a ML model or LLM or something, and it gets a CVE, EPSS will score it. And the reason is because what CVEs gives us is a unique ID that can be tracked across disparate data sources. So like the fact that a pen testing tool will say this will discover this CVE, and then our exploit data says this CVE is being exploited, and Metasploit says here's an exploit for this CVE, and we look at GitHub and there's a repository that says here's an exploit for the CVE. All of that can be tied to the CVE, whereas opposed to like an LLM vulnerability or something without a CVE, you'll get vendor A calling it the blah blah vulnerability, and this one's calling it that vulnerability, and like there's no way, especially programmatically, EPSS has no human in the loop. It's grabbing all this data automatically. Like it cannot correlate where there is no CVE. So there's no non-CVE, AI, LLM, whatever it is. If it doesn't have a CVE, it won't be in there.
No, it's interesting because we have a similar challenge with CPE. I will say, if everyone, my spiel on CPEs and why I feel that they are a great tool, but oftentimes cause a lot of confusion because of that unique identification problem. Very similarly, as they are only created when a CVE exists, which makes it very difficult to then identify packages where CVEs don't exist at.
Mm-hmm.
But we've got a couple more questions. I think one that's really interesting is, where do you see the future of EPSS going? What's next for EPSS?
So we could talk about LLMs. I don't see EPSS being built on an LLM, but I do see LLMs helping with some of the data going into it. So for example, like we've got I wrote a classifier that goes through GitHub repositories looking for code that looks like exploit code that is tied to a CVE. Now, and I did this several years ago before LLMs were in our vocabulary. And now what I'm rewriting it with is an LLM to say, I want to look at that code, feed that code in an LLM, and if the LLM summarize that code, now that becomes a variable in my input to say, is this in fact exploit code? Because we know there's hallucination and things like that. But I think that's part of the future. And then the other thing in the future is that we're exploring possibly some supporting features. So like right now, there's one data feed and it's the most recent. And when we retrain the model here in the next month or two, we're going to see that score jump from one day to the next. So like we're going to go on V3, then we're going to go to V4, and we're going to see some scores jump around. So maybe we're looking at some commercial support for like, you want to stay on V3 for a while and slowly transition, whatever that is, maybe some more behind the scenes information. I don't know, but we're looking at that for the future, trying to make more information available, but keep EPSS what it is, just trying to add more onto it.
Absolutely. And I think one kind of follow-up question that popped up here that is related, is slightly related anyway, is, what might be some examples of why one would use the EPSS score date and the underlying EPSS data model when matching to CVEs and say like a package release dates? Is the EPSS score intended to always be used as current?
I'm going to say yes. You should always look at the current, because basically that score is saying, based on everything we know right now, here's the probability it will be exploited in the next 30 days. It doesn't really do much good. Like we've got some vendor tools that will update once a week or something like that. And most of the scores don't shift. Honestly, it's like, I think when I looked at it, like 1,000 per day out of the 250,000 would shift, and it would only shift, like most of those 1,000 were shifting 1 or 2%, like not a whole lot. And like maybe 6 to 10 would shift from one end to the other end of the spectrum, like really small amount shifting. But and I forgot where the question was going. The date, right? So, but it doesn't do much good to look back last year and say, what was the score on this vulnerability a year ago? Because that's going to predict, 12 months ago to 11 months ago, probability of being exploited in that time frame. So you do want to try and keep it current, but it doesn't have to be like today. Like you could pull it probably once a week and still be just fine. Now, if you're really on the cutting edge and you're really concerned, like you're getting attacked constantly and you want to be really aware, then yeah, I would update it daily and keep up on it. But I would not let it go, definitely not more than 30 days, because a lot of stuff can shift in 30 days.
Absolutely. And I hate to sound like a broken record, but that's why I think this continuous approach to vulnerability management is so critical, because the information is constantly changing, and vulnerabilities that existed yesterday are vulnerabilities that didn't exist yesterday are going to exist tomorrow. And so making sure that you're constantly both scanning from like a component analysis perspective, but then more importantly from a policy perspective, when so that way you can have the latest up-to-date scores. So I know that there's we got 2 more questions. Maybe we have a chance to squeeze them in. If not, we can kind of take them offline. One was asked about the percentile and scoring differences, the slide that we showed up earlier. Really want to understand which one means exploitability and which one means risk.
So the exploitability is the EPSS score. That is between 0 and 1, and it is a probability. So like that middle column. And so like the top one is saying there's a 0.3% chance that will be exploited in the next 30 days. The fourth one, where it's 0.97, saying 97% chance of exploitation activity being recorded in the next 30 days. The percentile is a ranking. And so it is the same exact data. So like if that EPSS score shifts, the EPSS score is the output from our models. The percentile, if that shifts, the percentile will shift. So like if it goes up, it's going to be raised in that percentile. The ranking is going to go up. If it's shift down, the ranking will drop down. The percentile is just a ranking to sort of put it on what people would intuitively think is a linear scale. And that's all that is. And while we're on this slide, I see another question about, is there any spreadsheet where automatically calculating the EPSS score? You can download it. So like you see, there's a link. The QR code, I think, just goes to first.org/EPSS, but the link above that where it says, if you go here, there's a CSV where you can just download all of today's scores. So you don't need to calculate. It's not like CVSS where you have to gather stuff, estimate, and then put in your own calculator. Like these scores, what's shown on the screen here, that exists for every CVE at that link today.
Absolutely.
So,
No, and this, like I said, these slides will be shared on both the webinar as well. So you'll have all of this information for you to reference on your own. The first org APIs are also really phenomenal, and so I've had a really good experience using them up to this point. With that, I know we're at time, so I want to be respectful of everybody has going on. I cannot, give you as much praise and kudos, Jay. Like I've really learned a ton today. You have my brain working. I feel like I'm honestly excited to go back to some of my early statistics work that in ways that used to scare me away before. So maybe any kind of closing thoughts before I let you go?
No, the other thing maybe to mention is that the EPSS Special Interest Group is open to anyone, and we've got meetings every other week on Fridays, and we just sort of get together and talk about vulnerabilities and where EPSS is going, and if there's any new research, we'll talk about it there, that sort of stuff. So that's open if people want to go. It's through the first.org website.
Perfect. Well, you definitely have a new participant in me, so I look forward to seeing you that day.
Great. Thanks, Cortez.
Absolutely. It was great talking to you. Thank you all, everyone, for joining as well. Hopefully, you've gotten a lot of good insights and new information out of this, and look forward to seeing you at the next FOSSA webinar. Take care, everyone, and I'm sure this won't be the last time that you see Jay and FOSSA partnering. So
thank you.
Take care.